Hi, this is Mr. Max. I am doing a quick video on how to differentiate or finding the derivative of a natural log function, and at the same time I'm going to skip to another one that has to do with a um, trig function just quickly. Okay, the second one that I have is going to be slightly longer, so I'm going to put that on its own video. So let's look at part one. So when you differentiate a natural log function with respect to x, what you need to know, the general uh, rule of thumb is that when you do d by dx of the natural log of, say, a function of x, okay, it's always that function of x, right, that stuff inside, over the derivative of that stuff. If you remember it like that, you would not really have a problem whenever you deal with that. So basically, here I have dy by dx is going to be, again as I was saying, that stuff inside, the stuff inside, in this particular case, which is the 5x minus the natural log of x, and we're going to then find the derivative, okay, of that stuff inside. So the derivative of 5x is just 5, and the derivative of the natural log of x is just 1 over x. Now, pretty much we are done with the calculus. It's just a bit playing around with the with algebra a bit here. So that numerator have got the complex fraction. So let's write the numerator over its own common denominator. So the common denominator is obviously going to be x. So this is going to have 5x here, and then minus 1. I'm going to put all of this over the denominator, which was 5x minus the natural log of x. I'm going to go ahead and put those ones in brackets. Now, here's what you need to understand, that if you have a fraction, for example, so this is a complex fraction, okay? If you have a fraction, like example, let's say you have 3 over 4, let's say we divide by 5. Now, the olden way of doing this, you will be saying, okay, this is actually like 3/4 divided by 5. Then you say, well, that's 3/4 times 1 over 5, essentially giving you 3 over 20. Okay, but this is a very long way of doing things. So it's just we find an easy way to sort of do that. So what I'm going to do is I'm going to multiply here by 4 and here by 4. So essentially this is just multiplying by 1. Okay, and if I do that, these 4's in the numerator, they will cancel, leaving me there with a 3. And 5 by 4 is 20. Can you see that those things are exactly the same? So that's what I'm going to do here. I'm going to multiply here by x, and I'm also multiply here by x. That's what I'm going to do. Okay, just to clean up that complex fraction. That's what we always will be doing, and you better get used to those type of ways of doing stuff. Okay, so essentially those x's in the numerator will cancel, leaving you with 5x take away 1, and all of this, okay, mind the color of that line, all of this would be that x multiplied by 5x minus the natural log of x, and your work is done when it comes to that question. Okay, let's skip to the C part. I will do this one in a separate video. Okay, the C part, well, you have a basic trig function, and I hope that you know how to find the derivative of trig functions. Okay, right, essentially the part, what I'm doing over here is, again, remember, it's just to do a little bit of revision work. Okay, right. So let's see what we have here. Now, there is a constant multiple rule that I'm going to apply. So that means I'm going to take out the 3, and I'm going to do the d by dx of cosine of 2x. Okay, because it's constant multiple rule. So that 3 is going to be there, multiplied by. Now, what is the derivative of cosine? Well, if you have said minus sign, then you are obviously on the right path. But it's not all. We have to use the chain rule. So we need to find the derivative of the stuff inside, and the derivative of 2x is nothing but 2. Essentially, the calculus is done. It's just a matter of multiplying out and so on. So you've got 3 times 2 is 6 times this negative 1 here. So that gives me negative 6. You have sine of 2x. Again, that is the answer to that question.